Here we see a graph of a rational function, and we can get information by just looking at the picture. We can see the asymptotes in the actual graph. They ask us to find the domain of this function, the equation of the asymptotes, and the x-intercept and the y-intercept. So let's start with part A. The domain is just going to exclude one x value. As you can see, the graph never touches the value that corresponds to x equals 1. So that means we're going to write interval notation that excludes only the number 1. Open interval from -infinity, comma, to 1, open bracket, union together with open bracket, 1 to positive infinity. Part B is where we are looking for the asymptotes. First, we'll look at the vertical asymptote. It passes through 1 on the x-axis. That dotted line has an equation. It's the equation x equals the number 1. And so that is our equation of our vertical asymptote. I like to write the equation on the graph sometimes, so I'll remember this is x equals 1, that dotted line, the vertical asymptote. Okay, now for the horizontal asymptote, I see a line, dotted line horizontally that passes through -2 on the y-axis. Well, that one has the equation y equals -2. So that's the equation of our horizontal asymptote, and I like to identify that on the graph by just pointing it out, y equals -2. Part C, we're going to find the x-intercept. We just look at the graph, and we're searching for the location where the graph crosses the x-axis, the ordered pair. It occurs at the ordered pair xy equals positive 3/2, comma 0. That's between 1 and 2, so it's 3/2. Okay, the y-intercept is where the graph crosses the y-axis. So I look there, and it's very clear that it's crossing at y equals -3, and I always write my intercepts as ordered pairs. So the y-intercept is the ordered pair xy equals 0 for the x-coordinate and -3 for the y-coordinate.